Okay, blood pH. So this is a pretty chemistry intense problem, or so it seems. This first paragraph is just like chock full of like advanced chemistry stuff. If you've never studied chemistry or you don't remember this stuff, it's not a problem. We don't actually need to know any of the chemistry to be able to solve our equation. Of course, we wouldn't be able to do anything with that answer unless we actually understood the chemistry, but that's not the point of the problem. We just need to solve. So blood is a buffer solution. Carbon dioxide is absorbed in the bloodstream. It produces carbonic acid, lowers the pH. The body doesn't like the lower pH. It compensates by producing bicarbonate to raise the pH. It's a weak base. It partially neutralizes the acid. Great. So the equation is given. I typed it larger up here. All right. We don't need to understand how any of that stuff works. Next paragraph, X is the partial pressure of carbon dioxide in the arterial blood measured in torr. All right, well, X is what we're going to pay attention to. The last sentence here, the next one, that gives us our directions. Find, it says the partial pressure of carbon dioxide in the arterial blood, but that just means X. Find X if the pH is 7.7. All right, well, here's the X in the equation, so I'm going to solve for that. It's trapped inside of a log. Change the pH to 7.7 and then solve for X. All right, we'll drop 7.7 as the pH. Isolate the log. So we've got an algebra step. Get rid of that 6.1. And then I have log. The log is isolated. I need to get rid of the log, so I'm going to use the inverse property. The base of that log is 10. So I'm going to raise everything as a power of 10. Or, if you prefer, we can expand this log first, because it does have the division, log of 800 over x. I can expand that subtraction, put on hold the inverse property. We'll get to that in a minute. You could have done it first. If I do it now, it saves me on the algebra steps later. It comes out pretty close to the same, I think, either way. But okay, so the division, 800 divided by x, take the logs apart, becomes a subtraction, log of 800 minus log of x. Log of 800, pull that up on my calculator, is 2.9. Subtract the 2.9 to isolate the log of x. I do not want the negative log of x. So divide both sides by -1 to isolate the positive log of x equals 1.3. Now we're going to do the inverse property. Could have done it earlier. We didn't. Here goes. Raise everything as a power of 10. 10 to the power of, and the log base 10, those are inverses. They cancel, so I have just the x on the right-hand side and evaluate 10 to the power of 1.3 on my calculator. 19.9526. And then there's an equal sign. Sorry, it all kind of blends together. It's a little bit messy. Okay, 19 point, how many decimal places does it ask for? Does it even tell us? All right, well, 4, you're not going to go wrong with 4 decimal places. Sometimes you get away with less. 19.9526 would be my answer here. Final answer, the end. That is the partial pressure of carbon dioxide in arterial blood.